Now, the next part. Let's say we apply a force. Supergirl pushes in this direction to the left, okay? And she pushes with a force of, let's say, 500 newtons. To the left, I'll call it LFT. And Supergirl's pushing on that 500 newtons to the left, and she does it for a time, an elapsed time of 30 seconds. And I want to know, what's the change in momentum? How does she change the impulse? Or how does she change the momentum? What's the impulse she applies? So the change in momentum, which is the same as the impulse, the change in momentum is force times the elapsed time. Times the elapsed time. And that's going to be equal to 500 newtons times 30 seconds. That's to the left, because it's 500 newtons to the left. And it's going to be 15,000 newtons times seconds, or NS. To the left. Now, the car is moving. It's got a momentum of 40,000 kilogram meters per second to the right. Supergirl applies an impulse of force times the time, 15,000 newton seconds to the left. So it's going to change the momentum, and let's see what that is. So C, what's the final momentum? Let's see. The final momentum is equal to the original momentum plus the change in momentum, which is 40,000 kilogram meters per second. That's to the right. Now that's plus 15,000 newton seconds to the left. Now plus 15,000 newton seconds to the left is the same as minus 15,000 newton seconds right. So I'm just going to switch the sign and switch the direction. So that'll be plus delta P, which is a negative 15,000 newton seconds.
You can make them pressure like that off the wall.
Right.
Oh no.
Okay.
Lick it off the wall.
And that's going to be 25,000. 40,000 minus 15,000. That's going to be 25,000. I can say kilogram meters per second or newton seconds. Doesn't matter. They're the same units. So I'll write kilogram meters per second. To the right. And that's the final. So if nothing else happened, the momentum would stay the same forever. The only way to change momentum is to apply an impulse. Impulse and change in momentum are the same thing. The final momentum is equal to the original momentum plus the change in momentum. Now that I've got the 25,000 kilogram meters per second, if I wanted, I could figure out the final velocity, right? Because there goes my gremlin. Oh, it's all right. The example's over, so we don't need the gremlin anymore. Kind of dug the Levi seats. But anyway, 25,000 kilogram meters per second to the right is the final momentum. Momentum's mass times velocity. If I divided it by the mass, which is 1,000 kilograms, the new velocity would be 25 meters per second to the right. So in effect, Supergirl, by changing the momentum, slowed the car from 40 meters per second to the right to 25 meters per second to the right. Now we should talk about angular momentum.